Welcome. Let's try to solve another Leetcode problem. 1727. Largest submatrix with rearrangements. So for this problem, we are getting a boundary matrix. So this means the value is going to be 0 and 1. And the size is m times n. And you are allowed to rearrange the columns of the matrix. So that means we can rearrange the columns. So why are we going to rearrange it? Because we're going to return the area of the largest submatrix with matrix where every element of the submatrix is 1 after reordering the columns optimally. I don't understand. What is the meaning? So return the area of the largest submatrix. So this is okay. So within matrix. So it is within inside. Yeah, inside this matrix. So where every element of the submatrix. Oh, so every element of the submatrix is 1. Every element of the submatrix is 1 after reordering. I still don't understand what is the meaning of the English. So where every element of the submatrix is 1. Because there's some value, it is 0, and there's some value is 1. Where every element of the submatrix, oh, it means we're going to calculate some areas where every submatrix is going to be 1 instead of 0. We will not include anything about 0. So after reordering the columns optimally. Yeah. So now if we understand the problem, normally we should at least try to find some patterns. So for example, this is 1, 1, 1, this is 1, 1. Now we want to make the rearrangement. Maybe we're gonna shift this column like in the middle. Now we find these areas, it is okay because it's gonna have an area of 4. It's gonna be the maximum. How can we do it optimally? So this seems it's gonna be a greedy problem. Yeah. How can we rearrange it? Maybe we want to use the sorting. We're gonna sort it. So maybe this is let me use another color. Maybe it is better. Yeah. So the first one, maybe I'm gonna sort it like this. This is a 3, and this is a 2. Yeah. And from here, what about this one? This is a 0 because definitely we will not use it. Instead of a 1, we're gonna use a 0 because definitely if we have sorting, we're gonna use this layer. What about the last layer? The last layer is like 3, 2, and 0. Now, this is just from a 2D array. We're going to convert the 2D array into a 1D array. We're going to just use the 1D array. So inside of the array, it's going to be 0, 2, 3. Yeah, because this has already been sorted in increasing order, so definitely we can calculate it. So if this is a 2, so what's going to be the final result? It's going to be 2 times 2. It's going to be 4. What's going to be the last one? It's going to be 3. So 4 is going to be the maximum. So we're going to return 4. Yeah. So if the last layer is solved, what about the second layer? Yes, we can use the prefix sum to solve it. Now for the second layer, we can still use the prefix sum. So this is a 1, and this is a 2, and this is a 1. And after using the prefix sum, we can use, the maximum area is 3, because definitely after sorting, it's going to be something like 1, 1, and 2. So definitely from here, it is 3, it is the maximum. Yeah. Now it seems the problem has already been solved. Now what are we going to do? We just need to check the constraints if it is possible to use this kind of method. So we're going to check the layer by layer. We're going to use the prefix sum. So after using the prefix sum, definitely we're going to, after using the prefix sum, definitely we are checking each of the row. We're going to use the prefix sum. And then for each of the row, we're going to set it as a 1D array. So for this 1D array, we just need to use a sort. So after the sorting, definitely it's gonna work. So the final time complexity is gonna be m times n times log m. Yeah. So m times n is gonna be 10 to the power 5, and log m definitely it is less than 10 to the power 5. So the final time complexity is gonna be 10 to the power 5. Log 10 to the power 5 is gonna be a small value. That is why it's gonna work. Yeah. Now let's just translate the idea into the code. Yeah. First of all, let's just prepare the prefix sum. So for me, I'm going to use RC as a row and column. It's going to be length of the matrix and length of the matrix 0. So this is going to be the row and column. Now I'm going to use the prefix sum. So for R in range from 1 to R, and for C in range from 1 to C. Not 1 to C, just to C. Yeah, because we're gonna check the second row. From second row, we're gonna use the prefix sum. So the matrix RC gonna plus equal to matrix R minus 1 with C, but there is a condition. Yeah, so only if it has a value, and then we're gonna do it. Yeah, if matrix RC has a value, and then we're gonna use the prefix sum. If it does not have a value, it means it is a 0. Definitely we don't need it. So this is very important. Yeah, so for example, this is for this layer, this is 1, this is 1, it is okay, but this is a 0. Definitely we don't need it, because we're gonna check the matrix from the bottom to the top. Yeah, so from the bottom to the top. If this is a 0, definitely we will not include it. Only in this way we can find the maximum area. Yeah. Now we've already finished the prefix sum. Yeah, I think we've already finished the prefix sum, because definitely for this row, for the last row, for this one, it's gonna be 0. Normally 0 will not be included. It should be okay. Yeah, now we just needed to check the final answer. So I'm gonna set a result, and finally I'm gonna return this result. So for each row inside of the matrix, so currently this matrix is a prefix sum matrix, and basically it is a prefix sum of each row. Yeah, now I'm gonna check the row. I'm gonna use the sorted of the rows, because it's gonna be easier for my calculation. Yeah, and I'm gonna check the final result. So the result is gonna be the maximum of the result. I'm gonna use a check function. So this check function is gonna be this row. And finally, I'm gonna return the result. So what left behind is this function. So let me just finish this check function. Basically, it is checking the maximum area. So I'm gonna use a nums 1D array. Yeah, as this nums has already been sorted. So what I'm gonna do, I just need to enumerate the nums and find the maximum area. So I'm gonna set a result to be 0, and for I, n, maybe v, enumerate the nums, and the result gonna be the maximum of the result, and the area gonna be the current value v times n minus I index. So for example, yeah, so for example, this one, for the last layer, it is yeah, so for the last layer, it is 0, 2, and 3. Yeah, how can I check the maximum area? Basically, this is the index 0, this is the index 1 and 2. Now I'm checking the index 1. So for this index of 1, I have a value of 2. So this is a 2, and it's going to be n minus, and this index 1. It's going to be 3 minus 1, it's going to be a 2. So this means this area is going to be 4. Yeah, and this n going to be the length of the nums. So let me just use the length of the nums. Yeah, so finally I'm going to return this maximum area. It's going to be the result. So let's just check the time complexity before running the code. Yeah. So for here, this is a prefix sum. We used 2 for loops, so this is m times n. And for here, for each row inside of the matrix, how many rows? It is r. We have r rows. Yeah. And then we just use a check function. So for this check function, so here we used sorted of the rows. So for each row and sorted of the rows, it's going to be a column. Yeah. So basically, it is r. Yeah, we find each row r times log r, and we're gonna plus the result. So the result is gonna be the check function. This check function gonna be c. Yeah, so this is gonna be the time complexity. So basically, r times c gonna be bigger. So the time complexity gonna be m times n. So I think my analysis is there's something wrong with my previous analysis. It should be the maximum of r times log r and r times c. So normally this should be bigger, so the time complexity is going to be m times n. Now let me just run it to check if it works. As you can see, it works. Yeah. Now let me just submit it to check if it can pass. As you can see, it passed for all testing cases, and it's pretty fast. I think that's all about it. Thanks for watching. See you next time.